Hello folks, so today we will talk not exactly about SSI but quite crucial topic that actually follow the SSI principles. It's the local first architectures and local first software. So nowadays it's extremely popular to put everything on Amazon and use some super powerful platforms and move everything to the cloud. And actually it's the cool thing but not always fit all our needs. So one of the ways how we could scale and one of the ways how we could achieve a big amount of data without the powerful infrastructure and how we could achieve the security and SSI principles is the local first architectures and local first data. So idea is extremely simple. So it's so simple that it's super easy to explain. So practically all the user data stay on the user device, and to make this application working, your network connectivity is optional. You could work and operate fully offline, and all your data stay on the device. With this approach, we achieve a high level of security because everything is the local, so nothing could be stolen actually. The next is the access. You have the full access to your data, and you don't need to ask people to get the access to your data. It's accessible all the time. Another quite important thing that long now principle. So the long now principle say that you should use the data format that application independent. So it means that even if application will disappear, your data will be still accessible. So for example, a really good example that I use in my daily routine is the Obsidian. Obsidian is a knowledge management system that heavily based on the local first data. You have just empty files, so it's simple text files that even if you will throw away Obsidian, you still could work with it, you still could read it, it's still accessible for you. And for example, the verifiable credentials, as far as it's just simple JSON files with the signatures, follow this principle. And long now mean that you have the access to your data right now, and you could have it quite long term, and you have the persistent. So persistent wise, as I said, that we want to use already existing infrastructure. We don't want to reinvent the wheel. So it could be the simple file storage, or it could be some technologies that widely accessible. So next thing that the local first say that your data stay local, the connectivity is optional, but we still have the possibility to heavily contribute. And you already have seen a lot of applications that have the same approach, the Google Docs and all other things. But with the collaboration, we could use the CRDT, so it's some kind of data that allows us to exchange the differences and to maintain the local copies of the same data. So every party store their own local data and exchange the difference with the CRDT, and CRDT is the mergeable structures, so the zero conflict structures. And for example, CRDT is quite important part of the protocols. And for example, the Site3 protocol of the DIT element and some other DIT methods that follows the Site3, it's based on the CRDTs. So CRDTs could be quite interesting topic to talk in a separate video, but the CRDT in a combination of the local first architectures give us a possibility to collaborate and to have the protocols that could maintain the in sync copy of the local data. And in this way you have a lot of players that still keep their local data but have a possibility to collaborate. So why it's important for the SSI, because this architecture is heavily follow the SSI principles, practically the accessibility, transparency, security, consent, and all other things. So it's fit really well to the SSI, and your wallet could be the local first application, or you could have the SSI agent. If you haven't heard about the SSI agents, see my previous video. So you could have your local copy, you could have the consensus local copy that's spread between the different players for some type of data that you want to share with others. And yeah, so I believe that scalability wise it's really interesting topic, because instead of building the platforms, instead of investing some crazy money to huge storages and all other things, you could just utilize the user storage and user computation power, and yeah, you don't need to build something super powerful and give all your money to Amazon. You could just utilize the agents. Yeah, for sure, with this approach you have a not problem but challenge, that what will happen if user wants to have a backup, or what will happen if a user device will disappear. So then we have some other options, and in this place cloud it's more powerful, because we believe that Amazon will not disappear. We believe that cloud storages are more reliable, but we could achieve the same things with the some backup strategies of the distributed storages, and distributed storages maybe could be separate talk, how IPFS is working and how some other distributed storages is working, but it's crucial to understand that you have the alternative. This alternative is the local first data, that this data stay with the user, and this kind of architectures solve really a lot of problems that modern applications have, and in a quite simple way, that instead of keeping everything on your side, a user keep all the stuff on his side, and then you have protocols that allow you to query, collaborate, and get something from this data. For example, the Brave browser work this way. So intention tokens, you keep all your view history on the Brave browser side, but in the same time the advertisers could get some information on your consent. And this attention tokens is quite interesting topic in tokenomics, so if you have time, take a look to it. So as you see, we have a lot of interesting things. We have quite challenging topics in this domain. If you do something in a local first data, just let me know, write the comments. I'm keen to hear more what you're doing in this space. I keen hear more what you're doing in SSI. Subscribe to our channel, don't miss our videos, and yeah, for sure, provide some cool comments. I really like the feedback from people, and see you.